Happy Monday, everybody. Confinements of my own basement. Hopefully you had a wonderful Easter and a good weekend, and you spent a lot of time with your family doing some fun things at home, and just celebrating the holiday. It's Monday. We got to get back to sciencing, right? So I know you guys have continued to support us and like us and share us on Facebook, and you're hopping on the website and you're pumping up videos for us. So we really appreciate that, and we want you to keep doing that. And I specifically would like to see you keep doing that. So hopefully you're still enjoying yourself. Obviously, we're hunkering down still, and we're just going to keep pressing forward. So today, I thought it would be kind of neat to just touch a little bit on strawberry DNA. A little demonstration that we do in an experiment we do that involves extracting DNA from strawberries, and it's a pretty simple experiment. And these strawberries, obviously, these are not the best of strawberries. They've been sitting a while in the freezer. So these are strawberries that we didn't go out and purchase. I use these as a demonstration for most of the experiment. So just thought them out. Probably won't be able to eat these ones. I know I keep reiterating that we should obviously utilize any materials that we're using and not waste anything. So these we're not going to be able to eat because we're going to add a little bit of soap to them. So just wanted to make that pretty clear because these are not getting eaten after this demonstration. So that being said, so if we know anything about DNA, all right, it is like the blueprint or the cookbook of how things are made up, right? We have DNA. DNA is the acronym for deoxyribonucleic acid. Super long word, super fun to say. And I would encourage you to hop on the internet and kind of, look it up. There's a lot of information because it is information. It's information about us. It's the reason why, I have hazel eyes, or my son has blue eyes, or, and Rowan is off in the background right now. He said to tell everybody hello out there in TV land. So in any case, we have DNA in us. And now humans are considered diploid. Okay, we have diploid chromosomes. So basically we get two sets of chromosomes. Okay, so one from our moms, one for our dads. Okay, strawberries, okay, diploid, that's us. Strawberries are octoploid. So if you know anything about breaking a word up into its parts, do means two. Octo means eight. So strawberries have 8 sets of chromosomes, which is incredible because it's a wonderful fruit to be able to break down. There's so much that we can get from a strawberry because of the fact it's octoploid. Okay, so that being said, we're going to break down the walls of this chromosome and the membrane of inside the strawberry here, and we're going to be able to extract the DNA, and you're going to literally be able to see it. And I'll hold it up to the camera now. I keep reiterating. Hi, Mayor. I keep basically saying that I'm going to use stuff that you would have in your own home. Now, today I'm going to make an exception. I'm using a glass beaker, glass test tube. It's going to be easier for when I hold it up to the camera, as opposed to if I was to recommend using something for this experiment, I would use like a plastic container, anything that's transparent or translucent. You might have a hard time if you have something that's a little cloudy. So I would recommend using even a glass cup, something that you can see into so that you can see this experiment. Hi, Renee. Good to see you. Happy Monday. Hope you had a wonderful Easter. So let's go through a little bit of the background about DNA again. So there's some interesting facts, and you can search the internet for all of this stuff. A couple of the ones that I pulled off the internet and I've been doing research on. Wendy, good to see you. So humans, we're pretty similar. So, me and my son and you and everybody out there in TV land, we're 99.9% similar. It's that, 0.01% that kind of makes us different. Whether it's you got a receding hairline like Mr. Ralf, or you grow like this weird patch of stuff on your face, or you have pretty blue eyes, or you have a wonderful nose or beautiful ears. That's the difference in us, right? So it's the neat thing about DNA, but it's a very, very small percent. We're very similar. But the other thing I found is our DNA is very similar, 50% similar to that DNA of bananas, which is kind of funny, and cabbages as well. So similar DNA to fruit and vegetables, which is kind of weird. So I would encourage you to, when you do this experiment at home, search for as much information that you can on the internet. You got to look up these interesting facts. It's pretty neat to look up. And it takes up a lot of time. So by the time you get done researching, it'll be lunchtime and you can eat, right? Not these, though. Okay. So that being said, hi, Tracy, Kayla. Hi, good to see you. Riley, good to see you. So couple of things you need for this. Not much stuff in the way of materials. So you obviously need your strawberries, and I referenced this at the beginning of the post. We literally freeze some strawberries over time, so these are frozen, and then I just thawed them out. So these are not going to be able to be eaten. They're quite old, quite frankly, and they're very soft, so they're very squishy. You're going to need some water. Doesn't matter how much water. I just got a cup full of water. Okay. Again, I would use a plastic container, something that you can see through. Okay, could be anything. You could use a glass jar. You can use a glass cup. Anything that you can see through. I'm going to be using a glass test tube, so it's easier for us to see. And if I hold it up to the camera, hopefully, I'm hoping in the very end of this, you'll be able to see the strands of DNA separating themselves. Okay, you need some dish soap. Okay, and we're going to use soap because soap is going to break down. Obviously, if we wash our dishes with it, it has the ability of breaking down the fat walls. Okay, so soap is really good at breaking down fat. So what encompasses those molecules and those chromosomes and that DNA that we're trying to get to is a fat wall. In the cell membrane of the strawberry, there's a fat wall. So we have to break that fat down, and what better to use than dish soap, because it's going to break the fat down. Okay, we're going to need a little bit of salt, okay? And salt is going to break down the protein molecules. So that's the reason why we're going to use the salt. We're only going to need a pinch of salt. You're going to need a strainer or something to be able to strain and something to strain into. Obviously, I've got a little glass jar here, a little bit of a strainer. Now, here's the interesting thing. I didn't have any extra and excess coffee filters, okay? Oops, sorry, my apologies. So what I'm going to use for this experiment is some napkins. And anything that you can use when you pour liquid through it that you're going to literally drain, because we're going to want to get rid of the guts of the strawberry. We don't want the guts. We just want the juice. We want to break down the membranes of the cell, and that's going to be included in the liquid material. We don't want the guts. So, all right, that's about it for this, okay? Oh, last thing, you're going to need a bag, and I would recommend probably a freezer bag or something large. And it's a little bit more durable, has a little bit more of plyness to it. Only because when little hands do this project, they love to squish the strawberries, and quite frankly, what happens is that bag breaks. So if you don't have the big freezer bags, I would just say double bag your sandwich baggies. So I have 2 bags here, and I'm going to do it with 2 bags. That way, if the bag breaks, you don't get real, mess everywhere. But in any case, like I always say, messiness is the sign of a genius. So, do whatever you want to do. So I have 2 bags. So that's about it. So the first thing you want to do is you want to cut the tops off your strawberries. You don't want that green part. So we're going to cut the tops off the strawberries. And I'm going to use, it looks like I've grabbed about 6 strawberries for this, or 5. You can use 2 or 3. Again, the more you use, the more times you're going to be able to experiment with extracting the DNA. So I'm going to use enough so that we have a good visual. All right, let's see who's out there. Renee, miss you guys. Hi, Jess, Trace. Okay. All right, good. All right, so we've got my strawberries. I cut the tops off, and the first thing that you want to do is just stick those in the bag. Okay. So I'm going to stick my strawberries in the bag here. Okay, and we're going to get rid of the tops of the strawberry here. Okay, set that right there. Okay, and then you're going to close your bag up. Okay, and now I don't need to close my bag, but I'm going to break up my strawberries here. I'm going to show you I'm breaking them up. And what you want to do is you literally want to liquefy the strawberry itself. So we want to get it and basically make it a paste, or what we would say is, strawberry preserves, right? So that's the first thing that you want to do, is break this down so that we see a nice paste of strawberry. Okay, and sometimes what I tell the students to do is I say, just kind of press it down on the table here, and I'll move this down a little bit here, and you can see me, I'm pressing down. You don't want to smash or hit or do this too, violently, because that'll just encourage the bag to break. So I will say, give it a little TLC. You just want to, break it apart. So we've got a nice little paste there. If you notice, we got a nice little paste, and there's a lot of big guts in there from the strawberries. Okay. So what we want to do to make it more of a liquid, okay, we want to pour a little bit of our water in. Now, I asked Rowan to go grab me some water, and he said, well, how much do I grab? Doesn't matter. The more water that you add to this, the more liquidy it's going to be. Now, I wouldn't add too much water. I have in this container, there's about 6 ounces in here. Okay, I'm not going to use 6 ounces. I'm going to use just about 2. Okay, so I'm going to pour 2 ounces of water in here. Okay, now, the other thing that we want to add to so there's the water, there's the mixture. Okay, the other thing that we want to add to this is our salt. Okay, now you only need a pinch of salt. Remember, this is just going to break down the protein wall. Okay, so just a pinch of salt, and that's going to go in the bag. Okay, soap. Now, here's the important part of this demonstration. You don't want to use too much soap. You want just a drop or two. And when Dawn says that just a little bit will give you enough to break down the fat on your dishes or break down the food, they're on it. That's a true statement. In this instance, we don't want to use too much soap because we don't want a lot of foam. We want just a little bit of soap. We don't want to build up a foamy mess in our bag. All right, so what? Just a little teeny drop. Okay. All right. Now, that's our mixture. Now, we want to massage the bag. We want to just get that soap so that it's getting into our liquid there. We want to just get that into the liquid and mix up that salt in there. So what's happening right now is the soap and the salt breaking down the protein wall, and the soap is breaking down the fatty wall of that cell membrane. Okay, so we're going to expose, that material. So if you notice, I'm not making a lot of suds in here. There's not a lot of soapy suds, and you don't want that. If you get that, that's not a humongous deal. It just makes this project drag out just a little bit longer. So if you want to see the end result, you want less foam. If you want to make a foamy package, that's fine. That's fantastic. That's fine. And the kids love squeezing this and love doing this. Okay, but essentially, at the very end of this couple of minutes of massaging, you'll have a nice liquid there. Okay, now you can see in there's some large pieces of strawberry. That's the guts of the strawberry. We don't want that. We don't want that stuff. So got a lot of people chiming in here. Let me see who we got. So, what somebody had mentioned, if I could have a microscope, or if you had a microscope, it would be really neat to see what you could find if you dropped a little bit of this onto like a microscope film or a little glass jar, right? Okay. But I don't know how much you'll be able to see, but a microscope would just enhance this experience. Hey, Rowan, will you do me a favor? And Rowan's in the room. Rowan, you want to say hello to TV Land? All right, you got to get a little closer there, yeah? Hi, everybody. Okay, do me a favor. In the garage is some alcohol in the freezer. Can you grab one of those bottles? There is one ingredient that I did forget. I apologize. And Rowan's going to grab it right now, but we're going to still work with this because we don't need it just yet, okay? All right. Thank you for that comment, Jackie. Listen, this is a super, super wonderful thing to just be able to be doing this. So I love it. We miss you guys at Oh Wow. I miss all the children personally. So hopefully sooner than later, we'll be able to see one another again. All right. All right. So we're going to just set this in the background. Okay. All right. So there's our mixture. Okay. Now, remember what I said? We needed our coffee filter. Coffee filters work really well with separating the guts from the liquid. I didn't have the coffee filter. So again, I'm going to use what I would normally have. I'm going to have just a napkin. Okay. And we're going to use the napkin as a filter. Okay. Because we want to filter out the guts of our strawberry. Okay. All right. So then what you want to do is you want to pour that mixture very carefully. Now this will do two things. Obviously, you are going to find out how wonderful a napkin that you have, because if it is literally not allowing anything to go through, then you're doing a good job. You bought a wonderful napkin. Now, what I normally do is if possible, if things aren't draining real well, I'll squeeze very gently. I'll squeeze. And if you notice, there's what we want right there, that juice, that liquid. Okay, so that's actually coming out real nice. Now again, the more strawberries you use it with this, just the more juice you're going to have. Okay, we don't need a lot for mine. I'm only going to do this one time. So, all right, now, little napkin here just to wipe off. So you're going to have some wonderful strawberry juice. Now, that has exposed, because of the soap and the salt, has exposed a lot of that DNA into that liquid. Okay, and we're going to be able to see that in just a minute. Now, that last ingredient that I forgot about, okay, was isopropyl alcohol. Okay, now, I kept mine in the freezer, and obviously you want to make sure that the colder the better with this experiment, and it works so much more visually if you have alcohol that's been chilling, whether it's in your refrigerator. I kept this in the freezer, and it doesn't matter, it just has to be higher than 75% alcohol. So anything above 75%. This is 91%, there's 99, whatever you want to use, and we're only going to use a little bit of this, okay? You're not going to need a lot, okay? All right, so that was the last ingredient. We're going to wait still. We're not going to be using that, so. I'm just going to get rid of these guts here. All right, so if you see, all right, so there's my mixture, okay? That's all we need. Now, again, remember what I said. You don't need a super wonderful container to hold this, just something plastic, something. I'm using a little test tube here, and I'm going to keep my prongs up at the top so that we see what happens. So in any case, we're going to pour that juice right in my container. Okay, that's a fair amount. It's pretty much 3/4 or half a way up, almost a halfway, and that's all you need. Now, what we're going to want to see after we put this last ingredient is the separation. Now, you can talk about density in this experiment because there's a reason why things are going to separate in this instance. It's going to be, and I'm going to use my coffee mug here just to be able to set this down. Okay, you guys can see that? Pretty cool, right? All right, so the last thing that we're going to add is our alcohol. Now, you don't need a lot of this. You just need to be able to add this to the top. And there's a very delicate way that you want to do this. If you had, usually we have pipettes. I usually use a pipette for this, or a dropper, an eyedropper. I don't have one with me because most people aren't going to have those things. So what I'm going to do is I'm just going to literally gently pour the alcohol into the beaker, or excuse me, into the test tube. I'm going to show you how I'm going to do that real quick here. All right, you ready? All right, so let me move my coffee away so I don't pour any alcohol into my coffee. Goodness gracious. Okay, so I'm going to tip my test tube, and then I'm just going to pour just a little bit. Now, if you spill this on the ground, it's not a big deal. Let me see if I can show the camera here. Just a little bit down the side. And I'm pouring fast because I want everybody out there in TV land to see. If you notice, I've got strawberry juice right here. And then I've got, look at this. That's the alcohol. It is separated. Now there's a reason. Hey, Rowan, now you got to talk a little bit loud, but why is the alcohol sitting on top of the strawberry juice?
Because the strawberry juice is more dense.
Very good.
The alcohol
is more dense than the alcohol. So there's a little density experiment to this, right? So the alcohol is less dense than the strawberry juice. Now, what's happening inside of here, and I'm going to try and show you up close. We're going to get it real close here. If you notice, in your experiment, you'll start to see things separate, okay? And what it looks like are little bubbles or strands kind of moving their way from this part all the way up, okay? That's the strawberry DNA. It's the most interesting thing to look at. And if you had tweezers that you could stick inside there, you could literally pull the DNA out of the test tube or the beaker. Now it's making its way up the side here, and I'll show you in a second. But if you were able to get a set of tweezers in there or inside your beaker, I keep saying beaker, inside your test tube here, you could pull the DNA out. It almost resembles, Miss Madonna has referenced this as snot. It looks like snot. So let me see if we can get right off to the side here. If you notice, right on this side right here, there's some things starting to separate. They look like clear bubbles or strands, and they'll move their way from the strawberry juice up to the top of the alcohol. And there's your extraction of DNA out of a strawberry. Now, here's what I'll mention. We always talk at OWOW about modifying things and changing things up. So I use 91% alcohol. Things might work out differently if you used 75% or 99%. Will the reaction happen quicker? I will reference using something other than a strawberry. Try banana, try coconut, try a cantaloupe. See what happens. It might be much harder. You might not be able to extract the DNA, and there could be reasons why that happens. It could be because there's not enough information to be able to extract. I'm going to show you in a picture here because the DNA is really starting to separate itself. But modify your experiment. Change it up. This is something you can do differently. You can do it multiple times. Obviously, I can do this again. I've got extra strawberry juice here. And the DNA is still exposed in this. So I think the most important lesson to be learned here is DNA is a pretty cool thing to learn about because it's the makeup. It's the reason in strawberries, the different DNA, why a strawberry looks different than its brother or sister, right? One's bigger, one's smaller, one has, a different shape on the very bottom of it. Sometimes you see two lumps at the very bottom of a strawberry. Sometimes you only see one, but there's so many different things about a strawberry, and that's because of that really tiny percentage of the strawberries having different DNA, okay? Let me see if the camera will show this. I'm going to get real closer, but if you notice, it's a very clear, that little clear particle there, that is the DNA separating itself from the strawberry juice. Okay, so there you have it, little strawberry DNA on our Monday here. You can look online and find some interesting facts. Humans carry 8% of DNA of viruses that infected us a long time ago. And that kind of segues into this whole challenge that we're having with this coronavirus. Well, our bodies don't have the ability to fight off this virus just yet. So there are wonderful scientists out there doing some wonderful things, looking for, something to help us so that a vaccine or something to help us and protect us from this virus that's such a challenge right now. But that being said, some of the virus that affected us way back in the day that would kill off a lot of people, our bodies have 8% of that DNA that protects us from those viruses now. So really cool things to look at. I'm glad everybody was able to get up this morning and join us. Hi, Rock. Good to see you. Tracy said, would it work with other items like blueberries? That's a great observation, Tracy. And you know what? Try it out. See what you can find out. See if you use blueberries or raspberries. Try this experiment out. I know when we do this experiment, you can see online, we give you the directions. This is online right now. You can hop on the educator web source. You can hop on the family web source. But we provide you with the DNA. And if you had any questions, you could always ask too. Always reach out. It says, I appreciate that, Wendy. Listen, I'm just as engaged as you are, so I just appreciate you watching. Hopefully you guys learned a little bit. You laughed a little bit. I know this light's shining. It's bright light on my forehead here, so hopefully nobody's blinded right now. But go home, try this experiment out. The Wild Pals have some really cool things lined up for you for the rest of the week. I will be back with you on Friday. I'm not going to tell you what I'm going to do. It's going to be a surprise. I think it's really neat to be able to keep you in limbo and just kind of make you wonder what we're doing. Hopefully you have a wonderful rest of your Monday. I really appreciate you tuning in. Again, you can find us on www.owowkids.org. That's our website. The pull down tabs will give you all of this information. It's in lesson plan form. It's in direction form. You can find it. Please look us up on Facebook. Make sure you like us. Make sure you share us. And most importantly, make sure you support us. The wonderful IT people that we have working with us have got little buttons that you can, if you decide that you want to donate to the museum or you want to do something fun, just click on that button. Listen, we love you. We miss you. I'm having a good time doing this. I'd rather be in person doing this with you guys, but again, this is just as good. So have a happy Monday. Thank you for joining, and I'll see you on Friday. All right, guys.